In this video, we're going to talk about integration by part. Integration by part. We often need to integrate a function that is a product of two functions. Yes, and we use the integration by part formula. The formula says that the integral of u dv is equal to uv minus the integral of v du. So if I have a function like the integral of x squared sine x dx, I'll make use of this formula to integrate it. Now, the formula has u and dv. So I am integrating u dv. So what should I choose as u and what should I choose as dv? Look at it this way. I have x squared and I have sine x. If I differentiate x squared with respect to x, I'm going to obtain what? 2x. If I differentiate 2x with respect to x, I'm going to obtain 2. If I differentiate sine x, for example, I'm going to obtain cos x. If I differentiate cos x, I'm going to obtain minus sine x. If I differentiate minus sine x, I'm going to obtain what? Minus cos x. And so on and so forth. After successive differentiation of x squared with respect to x, we got 2, and 2 is a constant. So the idea is that choose the part of the function. Okay, I'm saying like it is a part now. We have x squared sine x. So we have sine x and x squared. So it's in two parts, x squared and sine x. So the part of the function that will produce a constant after successive differentiation should be chosen as u. Okay? The part of the function that will lead to a constant after successive differentiation should be chosen as u. And we can choose the other part as dv. And that dv should be a function that can be integrated using the standard integrals. Alright? So if I differentiate x squared with respect to x, that's the second derivative now of x squared with respect to x. I'm going to obtain a constant. Okay? Check. If I integrate sine x with respect to x, the integral of sine x dx is going to produce minus cos s plus c. So integrate sine x dx to obtain the negative cosine of x. That means we can integrate sine x easily to get what? Minus cos x. So there is actually a mnemonic that we use to determine which part should be made equal to u and which part should be made equal to dv. This is the mnemonic LIATE. LIATE. L stands for logarithmic, I stands for inverse, A stands for algebraic, T stands for trigonometric, and E stands for exponential. I just showed you why we should choose x squared as u, because after successive differentiation, x squared will lead us to what? 2. This helps us to choose the part that should be set equal to u. Okay, let's use this function as an example. X squared sine x. X squared is algebraic, that's A. Sine x is what? Trigonometric, that's T. So this one is x squared because it is algebraic, and this one is what? Sine x because it is trigonometric. A comes before t, so I should choose u as x squared. Alright, so if I have x squared ln x, for example, x squared is algebraic, ln is logarithmic, so which one should I choose as u? I should choose ln x as u because logarithmic comes before what? Algebraic. So this one will be u, and this one will be what? dv. So in this case now, I'll choose this one as u, and this as what? dv. So I'm going to integrate this function now using integration by parts. Just keep watching. The formula is still there on the board. So we have said that let u be equal to what? X squared. And let dv be equal to, dv is everything here, the remaining part of it, sine x dx. Sine x dx. That is it. So from here, I'll differentiate u with respect to x. That's du dx. And du dx is equal to what? 2x. So from here, if I make du the subject of the formula, I have the u equal to what? 2x dx. Okay. This is the v equal to sine x dx. So to get v, I will take the integral of both sides. Alright? So if I integrate the v, that's v. So the integral of sine x dx is minus cos x. Okay? So let's apply the formula straight. The integral of u dv is equal to uv minus the integral of v du. So therefore, the integral of x squared sine x dx is equal to u is what? X squared plus v minus cos s. Minus cos s. Then minus the integral of v. V is minus cos s minus cos x du. That's v times du. And du here is equal to 2s ds. As 2s ds. Take note, we'll not add c to this minus cos x. Normally, if we integrate sine x ds, that's the indefinite integral of sine x ds, we are supposed to add an arbitrary constant c to it. But in this case, we do not add it. Okay, we don't add constant. So this is now equal to what? This is minus s squared cos s. This is minus 2. Minus 2 can come out. And if it comes out, this becomes plus 2. We now have the integral of x cos s ds. So the integral of x cos s ds is not a standard integral, unlike the integral of sin x ds, which is equal to minus cos s plus c. Okay, just the same way, this is not a standard integral. The integral of s squared sin x ds, we have to use the integration by parts. Okay, the formula for integration by parts to evaluate the integral. This integral will also be integrated using integration by parts. So what you should know now is that there are times where we have to apply the integration by part formula more than once, more than twice, more than 3 times. It depends on the way the function is. Okay, so we are going to apply the process again for integration by parts on this integral, the integral of s cos x dx. Let me integrate this one now. That is the integral of s cos s ds. So we know what to choose as u now. You let u be equal to x. Remember, this is what we are integrating. Okay, just that this integral led us to this. So to evaluate this, we have to use the integration by part formula again for it. So let u be equal to x, and if I differentiate u with respect to x, that's du dx is equal to what? 1. And this implies that du is equal to what? Dx. If you cross multiply, this is what we have. So dv is equal to cos s dx. So that if I integrate both sides to obtain v is equal to, what is the integral of cos x? That's the integral of cos x dx is sin x. Differentiate sin x to get cos s, integrate cos s to get sin x. So if we apply the integration by part formula on this, it means that the integral of, okay, let me do that here. The integral of x cos s ds is equal to, the formula says uv minus integral v du. So what's our u here? U is x, what's v? Sin x. Minus the integral of v, which is sin x, and what's du? Dx. So we have x sine x. Okay, integrate sine x dx to obtain minus cos x. Minus cos x. So this is minus cos x. And this is equal to x sine x minus is a plus cos s. So the integral of x cos s dx is this. Let's lift this in place of this now. Therefore, the integral of x squared sine x dx, which is equal to this, minus s squared cos s plus 2 in bracket. In place of everything here, I'll now write this, because this, which is this, is equal to this. You get the point? So this is x sine x plus what? Cos s. The integral of x squared sine x dx is equal to minus x squared cos s. 2 times s sine s, that's 2s sine s. 2 times cos s, that's 2 cos s. We can now add the arbitrary constant to it. So this gives the integral of x squared sine x dx. So this is not all for integration by part. Yes, this is not all. For example, I can determine the integral of the sine inverse of x dx using this integration by part formula. Yeah, it is interesting to know that this integral can be evaluated using integration by part. So keep following, keep supporting by subscribing to this channel, like the video and share it to your friends and to your classmates.